So to know about mutations, it's good to start here from the template strand on top. This is a template strand of DNA. You can tell because A, I wrote it, and B, I have it written as 3' to 5'. So this is what is called the template strand because the protein itself and the mRNA that's about to be synthesized is all based on that strand here, not the non-template strand, but the template strand. So T is going to go with an A, and what we're going to see is A is going to go to what you would want to say T, but remember this is RNA, so that's U, C to G, T to A, and then C to G, A to U, U, and then another U here, and then A. So now what we can do is we can use this guide here to tell us which amino acid is going to go with which mRNA codon. So AUG is going to be ME, oh, let me put that in blue, is going to code for the protein MET. And then I'm going to also, let me just draw a line here to show that this is all different. So that's MET, right? Because you have A, then you see the second letter is U, and then you have G here. So that tells you that. And then here you have A, and then G. So there it is, AAG. So that's going to tell us that the amino acid here is LYS. Then U is going to be PHE. And then UAA, that's UAA, and that's going to be the stop codon. This is extremely important for all proteins and all amino acids, just so we know that the protein needs to be stopped being made. You don't have to go on forever. So let's first look at a silent mutation. Silent mutation. Why is it that we call it silent? Well, let's say that we see that this A here and the triple A is going to be replaced with, so here it is right here, is going to be replaced with a G, which means that this here, this G is now going to be replaced with a C. And so it's now UC, which is still coding for PHE. So what we see is even though there was a mutation in the DNA, which ultimately led in a change in the RNA, we still have the same amino acid that was there before. It's still PHE. It's called silent because there is no change in the amino acid. All right, AA for short. All right, so that's a silent mutation where there's no change in the amino acid that it's coding for. If you're lucky, whenever you have a DNA mutation, that's what you would end up with. So let's look at a different type of mutation. What if we saw a missense mutation? We'll go back to the same one here. It's back to its normal AAA, UUU, and it codes for PHE. But instead of AAA, what if I just replaced it with, let's say, I'm sorry, CTA, and then this codes here, C to G, T to U, I'm sorry, T to A, and then A to G. And then you have GAG, GAG, that's going to be now coding for GLU as your amino acid, right? And remember, this mRNA itself has also been a mutant, right? And so what we see is that our amino acid is no longer PHE, it's now GLU. So that tells us that we're going to have a completely different protein here in regards to, not completely different, but this section of it is quite different, which means that the protein itself may not be functional or may not work as well as it did before. A missense is when you see a change in amino acid, right? That's when you see a change in the amino acid that's been coded for, right? So now we're going to get into a very specific type of mutation now known as a nonsense mutation. So what I'm going to do is we're going to take this codon here and we're going to replace it with ATT. A, T, T, which now means that this middle one here will become U. Oh, sorry, I missed. Let's see, that's this here is a C to G. But then this codon here, this one that just got mutated, that's going to now read as U, A in the mRNA, which means it's no longer going to be lyse. It's now going to be the stop codon. And this is why it's called nonsense. Notice how it goes from MET to stop. Before, this here was the stop codon, which means that the protein stopped here. But now we have way up the line a message for the mRNA to be stopped, or the protein to be stopped. And now what we see is that the DNA, the DNA is coding for a premature stop. A stop before it's really supposed to happen in the protein. This obviously has very bad results for any protein, because now is it not only going to be functional because it has something that's like where it's not supposed to be, it more specifically is not functional because it's literally incomplete. Now, a frame shift mutation is a very effective one in regards to how much it changes the protein. It has a huge effect as well, very similar to a stop, but in terms of its scaleness of effect. And it's actually very, it's amazing how one small thing can cause a huge change. And let me just get right into it. Let's say that instead of replacing one of these entire codons, I actually add an extra codon here. Let's say I add an extra T right there. So now this everything from here on is going to be shifted to the right. So then what we'll see is that it becomes T here. This becomes C. That becomes A. That becomes A. That becomes A. This T becomes one of those other A's. And everything is just shifting over. And then you see that this also becomes A. And what you'll see is that none of these here are valid anymore. All of these amino acids are going to change. So we're going to see, so remember this is lysol, PHE, and stop. I'm actually going to keep those there just to emphasize how different it's going to look after I do the coding here. All right, so T to A, C to G, A to U. And then now, let me just put this in green to emphasize that these are the new mutant mRNA strands. And then I'm going to put let's say like baby blue. Oh no, green for the mutant there. And then for the mutant amino acids, I'm going to put like a dark green. So AAA, that codes for AAA, codes for LYS. So that actually still stays the same. Then you have GUU. GUU becomes VAL. Notice how it's no longer PHE. The insertion was here, but we're now seeing it affect the protein or the amino acid here later on above it. Instead of, and then now it has AAA, so it's UUU, and then U is now PHE. So instead of being a stop codon here, where this would normally stop, this becomes PHE. And it may go on and on and on for a very long time, just because now everything has literally been shifted out of order. A frame shift mutation is when an insertion, what we just did, or even a deletion causes all of the following amino acids to change, because you're literally changing all the letters preceding it, because you're now inserting extra information. You're not just simply replacing an entire codon. Best of luck on your exams.